Exercise 4.34. Determine the first four terms in the expression of the Madelung constant calculation for the cesium chloride structure. So on the screen, you are looking at the cesium chloride crystalline structure. Without losing generality, let's assume this is chlorine minus. And then let's assume this silence is D. Now let's look at the first shell of ions. There's 8 blue spheres are the 8 cesium plus ions surrounding this chlorine minus. The distance between these blue spheres and the center ion is the same. Now let's give the XYZ coordinates to the center. Let's assume the coordinates of this chlorine minus is 0, 0, 0. And then the coordinates of this one, let's say it's half, half, half. And this one, negative half, 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 etc. The distance between this cesium plus and this chlorine minus is the square root of 3 divided by 2 times the silence. The square root of 3 is 1.732 divided by 2, that's 0.866. So this distance is 0.866 d. Same here, 0.866 d. Same here. All right? And again, this chlorine minus feels attraction from this 8 cesium plus ions. Now we need to find the second shell of ions. These ions should have the same distance to the center. So we find 6 of them. 1 on top, 1 on bottom, 1 on the front, 1 on the back, 1 on the left, 1 on the right. So these 6 chlorine ions form the second shell. Now let's look at the distance. Well, we know this distance is 1/2 of d, and this is another 1/2 of d. Therefore, the distance between this chlorine minus and the center chlorine minus is exactly 1d. 1 silence of this yellow cube. All right? So now this is the second shell. The third shell is also made of chlorine minus ions. There are 12 of them. So which 12? 1, 2, 3, 4. All right? And then 1, 2, 3, 4 in the middle. And finally 1, 2, 3, 4 on the bottom. So this 12 chlorine minus ions have the same distance from the center. So let's just look at one of them. Let's look at this one, this 2. Okay, the distance between this chlorine minus and the center is the square root of 2 times d. Why is that? Okay, so this distance is d. This distance is also d. Therefore, this distance is the square root of 2 times d. So now we have a total of 12 chlorine minus ions with a distance of square root of 2 times d from the center. All right, that's the third shell. What about the fourth shell? Okay, the fourth shell is going to be a little bit tricky here because they are not showing in this picture. They should be blue spheres. So you will have to imagine we shift this one up by a distance of d. This one up by a distance of d. This up by a distance of d. This one up by a distance of d. So you need to imagine there are 4 new blue spheres. Okay, over there. And what's the distance between these 4 blue spheres to this center? Well, if the coordinates of this red sphere at the center is 0, 0, 0, and then let's say, well, this one has a coordinate of half, 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 then the blue sphere on top of this one should be half, half, and then 3 halves. All right, because you need to shift this 1d distance. So it becomes half, half, 3 halves. All right, and the distance between this blue sphere on top of this one in the center is the square root of 1/2 squared plus 1/2 squared plus 3/2 squared. And then you can simplify this to be the square root of 11 divided by 2 times the side length of this cube. All right. And how many blue spheres constitute the fourth shell? Well, there are 24 of them, because you can have this 4 atoms shift up. You can have this 4 blue spheres shift to left, this 4 shift to right, this 4 shift to the bottom, and this 4 shift to the front, and the back 4 shift to the back. So you have 4 blue spheres in each of the 6 directions: up, down, left, right, and from back. So you have 24 such blue spheres. Now let's look at the summary here. The first shell contains 8 cesium plus ions. All of them are on the corners, the 8 corners. The coordinates of this 8 cesium plus ions are 0.5, 0.5, 0.5, and then 0.5, 0.5, negative 0.5. So basically you just change the signs, and you have 8 of them on the corners. Now what about the second shell? There are 6 chlorine minus in the second shell. So this one, this one, this one, this one, and front and back. And the distance is just 1 side length of the cube. All right, so second shell, they are just 1D away from the center. And also over here, I have their coordinates: 1, 0, 0, negative 1, 0, 0, 0, 1, 0, 0, negative 1, 0, and then 0, 0, 1, and 0, 0, negative 1. So if this axis is the z-axis, you are looking at this on top, this one on the bottom. So we're talking about this one. This is 0, 0, 1. This is 0, 0, negative 1. So we have a total of 6 chloride in the second shell. Now we have 12 chloride in the third shell. This is a little bit tricky. The coordinates are 1, 1, 0, negative 1, negative 1, 0, negative 1, 1, 0, negative 1, negative 1, 0. So this 4, I'm going to show you where they are. They are here, here. Oh, I'm sorry. Here, 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 and here. So they are at the corners of this big square. All right, 1, 2, 3, 4. The distance between this sphere and the center is square root of 2 times d. Again, 1, 2, 3, 4. 4 of them are on the corners of the middle big square. And there are 8 others. There are 8 others. 1, 2, 3, 4. 1, 2, 3, 4. All right, so you have a total of 12 chlorine minus in the third shell. And again, the distance between this one and this one is also square root of 2 times d. All right, so this is 1d, this is 1d. Therefore, from here to the center, it's square root of 2 times d. And then the fourth shell. The fourth shell contains 24 cesium plus. Again, you'll have to kind of imagine shifting this 4 blue spheres up, this 4 to the right, this 4 to the left, this 4 to the front, the back 4 to the back, further to the back, and the bottom 4 shift down by 1 side length of this yellow cube. And we have their coordinates here. I did not enumerate all those coordinates, so I think I put 1, 2, 3, 4, 5, 6, 7, 8 there. But then you can put this 1.5 or negative 1.5 in the middle as the y coordinates, or here as the z coordinates. And that's why we have 24 such cesium plus with this kind of coordinates. And this is the fourth shell. And this 24 cesium plus ions are 1.658 d away from the center. So how did I get this number? This is actually the square root of 11 over 2. How did I get square root of 11 over 2? Well, it's just the square root of 1/2 squared plus 1/2 squared plus 1.5 squared. And that's actually just this number. Oh, and then you take the square root of the sum of the squares of these three numbers. You get 1.658. Now, finally, we can compute the first four terms in the calculation of the Madelung series. The first one, we have 8 Cesium plus ions, counter ions. Because it's attraction, so I put a negative sign here. The distance is 0.866 d, and I got the first term, negative 9.2. This is the second shell. We have 6 chlorine minus ions in the second shell. This is repulsion, so this is positive. The distance is 1, so we have 6 over 1, which is 6. The third shell, we have 12 chlorine minus ions. The distance is square root of 2, which is 1.414, and by doing this division, we get 8.5. That's the third term. Finally, 24 Cesium plus. This is attraction, so negative 24 divided by the distance. The distance, again, this distance is simply the square root of 1.5 squared plus 0.5 squared plus 0.5 squared, and then you get 1.658. So over here, this is the attraction, this is the repulsion, this is repulsion, and this is attraction. All right.